What if I told you that the recipe for a chocolate cake and the chemical formula for, say, water follow the exact same fundamental rule? It's true. Today, we're going to uncover this really powerful concept that lets us see the world just like a chemist does by breaking everything down into its most basic ingredients. So think about a cake for a second, right? You put in flour and sugar and butter, but once it's all baked and you cut a slice, how much of that one slice is actually sugar? It seems like a simple question, but believe it or not, that's precisely the kind of question chemists ask about every single thing in the universe. And as you might guess, chemists have a pretty brilliant way to answer that question. It's like they have this special kind of recipe, one that reveals the exact proportions of every single ingredient inside any substance you can think of. And that recipe, it's called percent composition. Now, the official definition sounds a little fancy, the percentage by mass of each element present in a compound. But really, all it is an ingredient list for molecules. It just tells you exactly what something's made of and how much of each part is in there. Simple as that. Okay, let's dive into this and make it super clear. On the left, you've got your standard cake recipe, right? It lists your flour, your sugar, your butter. Well, on the right, a chemical formula like H2O for water does the exact same thing. It's the chemist's recipe listing the elemental ingredients, in this case hydrogen and oxygen, that make up the final product. See the connection? So the big question is, how do we figure out those exact percentages? Well, it all comes down to this really simple, universal rule. And please, don't let the word calculations scare you off, because this is something you already kind of know how to do. It's all about the part versus the whole. Here's how it works in just 3 easy steps. First, you find the mass of the one ingredient you're interested in. That's the part. Second, you find the total mass of the entire thing. That's the whole. And finally, you just divide the part by the whole and multiply by 100 to turn it into a percentage. That's it. I told you it was simple. All right, let's put this rule into action. We're going to start with a super simple real-world example, just to prove how intuitive this part versus whole idea really is. Okay, imagine we mix 20 grams of sugar with 30 grams of salt. The total mass, our whole, is 50 grams, right? So to find the percentage of sugar, we take its mass, the part, which is 20 grams, divide it by the total whole, 50 grams, and multiply by 100. Boom, that gives us 40%. Same logic for the salt gives us 60%. See? Totally straightforward. Now for the cool part. Let's take that exact same thinking, that exact same math, and apply it to an actual chemical compound. I promise you, the process does not change one bit. Now, what's really interesting about this slide is how much it looks like the last one. We're applying this same rule, but this time to a water molecule, H2O. In chemistry, instead of grams, we use something called atomic mass units. So an oxygen atom has a mass of about 16, and the 2 little hydrogen atoms each have a mass of 1. That makes our whole molecule's mass 18. The hydrogen part is 2, divided by the whole of 18, that gives us 11.1%. And for oxygen, its part is 16, divided by 18, which is 88.9%. It's the exact same part over whole rule we just used. At this point, you might be thinking, okay, that's neat, but so what? Why does this actually matter in the real world? Well, it turns out this simple little calculation is actually critical in almost every aspect of our lives. Seriously, this simple math is everywhere. It's how they figure out the nutrition facts on your food, it's used to check the purity of gold, and even to measure tiny amounts of pollutants in our water. But maybe the most important place we use it is in medicine. Just think about a pill for a second. Knowing that the right percentage of that pill is the active medicine and not just some filler, well, that can be a matter of life and death. The crucial point here is precision. Percent composition is what allows for the incredible precision we need to make modern medicine both safe and effective. So now you get it. You understand the concept, you know how to do the calculation, and you know why it's so incredibly important. You've basically just been handed a new tool to analyze the world around you, to see things the way a chemist does. So let's put that new tool of yours to the test. Let's say a protein bar weighs 50 grams, and it has 20 grams of protein inside. What's the mass percent of protein in that bar? You know exactly how to solve this now. It's just a part over whole question. And the answer, of course, is 40%. You just did it. From a simple slice of cake to a life-saving pill, the fundamental rule for understanding what something is really made of is exactly the same. You now have the tool to see the hidden recipe in everything around you. So, what are you going to analyze next?